All right, so just like we did in an earlier problem, when you graph it in the standard window, which is negative 10 to 10 for both x and y, we are not able to see where those two graphs cross. And remember, that's what we're looking for when we're asked to find the solution to a system of equation. We want to know where the graphs intersect. We can't see that here. So we're going to have to change our window. We're going to have to zoom in or out, which is really easy to do on Desmos, but you can also do it with your graphing calculator. Let's take a look at what it looks like when we zoom out a little bit. Okay, so when we zoom out a little bit, we can see that those two graphs cross at the point for negative 15. So we know that that is our solution. Now, if you were using your graphing calculator, you would have to probably trace to figure that solution out, but on Desmos, you can just click on that point and it'll highlight the solution for you. So we know that the solution is the point for negative 15. Now, how do we solve this algebraically? So there's lots of ways to solve this algebraically. If you use a substitution, maybe you solved one of your equations for y and plugged it into the other equation. If you use elimination, maybe you added the two equations together. I personally prefer to use elimination in this case. So I would say 5x minus y equals 35, and then 3x plus y equals negative 3. And what I notice is that I have a negative 1 in front of one of my y's and a positive 1 in front of the other y, which means if I add these two equations together, that y is just going to become 0. So I add the two equations, and I get 8x plus 0y equals 32. And now I've got an equation I can solve for x. So x equals 4. And then once I know one of my solutions, or one part of my solution, I can plug it back into one of the other two equations that I started with originally. So I'm going to take that and I'm going to plug it into, let's say 3x plus y equals negative 3. So I'll have 3 times 4, which is 12. And then I subtract 12 from both sides, and I get y equals negative 15. And then I see that I get the same solution for negative 15. When you're solving these, you might have a preference. And there's pros and cons to both. With the graphing, as long as you have access to graphing technology, you can find that solution pretty quickly. But if you don't have access to graphing technology, you would have to graph that system on your own, on paper, and hope that you're exact enough that you can actually locate your solution. And if it's a fraction as a solution, if it was negative 15 and 1/3, that would be really hard for you to see on your graph if you're graphing it by hand. So that's probably the cons to graphing. Pro to doing it by using algebra is that you can find the exact solution. There's no doubt in your mind that that will be your solution. The cons is it can take a little bit longer.